A very good day to doctor. So I'm Yo Chun Hong from Expert Group 4, and today I am going to be present on the correction on SPTN number N60. So our expert groups 4 consists of 6 members, which are Alif, Hairul, Husni, Shafika, Noor, and me. So what is SPT? So before that, what is SPT? So SPT is standard penetration test. The definition of standard penetration test SPT is the number of hammer blows, which is specified as 63.5 kg, dropped at a height of 760 millimeters to advance a split spoon sampler of 450 millimeters into the soil at the bottom of the borehole. So the purpose of standard penetration test is to assess soil density, relative density, and also the bearing capacity in sands and or silts. So the results from the standard penetration test, which is the SPT numbers obtained, normally we have to correct it based on 60% energy transferred to the sampler due to various uncontrolled factors such as the depth of sampling, length of rod, size of borehole, height, and also efficiency of the hammer used. The formula at the left shows how to calculate the corrected SPTN number, which is N60 equals to EMCB CSCR over 0.6 times N, where EM is the factor of energy used, which is 0.7. CB is the factor for size of borehole, which is 1.05. CS and CR are the factors for the equipment used, which are 1 and 0.95 respectively. Finally, we have the N, which is the field SPTN number. The first table shown in the top left is the table for for energy use. The SPT hammer efficiencies based on BNBC 2015 table 6D4 shows different types of efficiency coefficients with different types of hammer and the release mechanism of the hammer, while the table next to it was the table for correction factor for CB, CS, and CR. The borehole, sampler, and rod correction factors based on BNBC 2015 table 6D5 shows different factors, which are bore die factor, sampler correction, and also rod length correction with their respective correction factor. The factors shown above are normally applied. However, those factors may vary depending upon the availability, such as the standards from the manufacturers, whether they comply with the UL code or other standards. Correction may be made with respect to overburden pressure and is expressed as suggested by Whiteman Bowles 1988, which is a simple version of the corrected SPTN number correlation, which is the N prime 60 equals to N60 times the square root of 100 divided by sigma prime naught, where sigma prime naught is the effective vertical stress and depth of interest. Sigma prime naught is the total effect, can be found by minusing the total vertical stress due to weight of the soil and other applied loads by the pore water pressure exerted by the water withdrawals, where the total vertical stress is calculated by multiplying the unit weight of the soil with the depth. So this is the work example for how to calculate the adjusted SPTN number. So SPT is conducted in a sand deposit at a depth of 20 meter. Water table is at 8 meter below ground level. If the N value is 40, find the correct N value. Unit weight of sand above water table is 18 kN per meter cube, and saturated unit weight of sand below water table is 19 kN per meter cube. Take the unit weight of water as 10 kN per meter cube. So the solution is as follows. So the SPTN value based on 60% hammer efficiency is equal to EM CB CS CR divided by 0.6 times the N, which is 46.55. Next, we want to calculate the adjusted effective SPTN value. So before that, we have to calculate the effective overburden pressure, which is the summation of the multiplication of the unit weight and the depth, which is gamma 1 Z1 plus gamma 2 Z2, which is 8, which turns out to be 252 kN per meter cube, and the effective stress would be 252 kN per meter cube, since the water table is far below. Next, we just plug in all the values to find the N60, which the final answer is 29.32. So in conclusion, correcting the standard penetration test SPTN value to N60 is a crucial step in ensuring consistency, reliability, and accuracy in geotechnical site investigations. The raw N value obtained from the field is influenced by several factors such as hammer energy efficiency, rod length, borehole diameter, sampler configuration, and overburden pressure. Without proper corrections, the N value can lead to misleading interpretations of soil strength, density, and liquefaction potential. The correction to N60 standardizes the energy delivered during testing to a reference efficiency of 60%, allowing for meaningful comparisons across different sites, equipment, and investigations. Further adjustments like overburden correction to obtain the M'60 enhances the applicability of the data in advanced soil behavior analysis. So that's all from me. Thank you.